are genotypes related to phenotypes? But whoa, those are some big words. So when you see this word genotype, what does it kind of look like? Or what does that beginning word geno kind of remind you of? Yeah, Samuel says it looks like the word genes. So then what do we think a genotype is? We know we're talking about genes, but specifically what about them? Okay, Mosey Heat says the type of gene, right? And last night we learned the word allele. Okay, so I'm actually going to write down, when we're talking about genotype, we're talking about the combination of alleles that make up your genes or your DNA. And when we see this word allele, we're talking about the different types or versions of a trait that you can inherit. And what were those two options that we talked about last night? So we mentioned like Dwayne "The Rock" Johnson going up against someone puny like me. What are those different alleles that someone can inherit?
Recessive and dominant.
Perfect. A dominant or recessive allele for that trait. And when we're talking about dominant alleles, what do we typically use to describe them? Capital or lowercase letters?
Capital.
Capital, right? So I'm going to use like a capital R. And what about recessive traits? Capital or lowercase? For recessive traits, do we use a capital or lowercase letter? Yeah, Samuel says lowercase. Perfect. So when we're talking about genotypes, we're just talking about the combination of those alleles, those dominant and recessive traits that make up your genes and make up your DNA. But then what does this word phenotype mean? So I'll give you a hint. It still starts with the letter PH.
Isn't it your body traits, like what actually shows?
Okay, your body traits. I like that.
Not physical traits. Some say.
Traits. Yeah. So when we're talking about phenotypes, we're talking about your physical traits or your physical characteristics. Basically, what you look like. So I'm going to write down what you look like. And what are some examples of physical traits that we can point out?
Like hair color, eye color.
Perfect. Hair color, eye color. What else?
Color of the skin.
Yeah, skin color.
Maybe like, I don't know, like glasses. Like, is
yeah,
that?
We could say like, yeah, we could say like your eyesight. Sure.
Yeah.
All right. What else? So we've got hair color, eye color, skin color. Even things like hair texture are determined by your genotype as well. Okay, so all of these characteristics, everything that describes what you look like, is determined by your genes, by your genotype. And today we're going to be looking at what some of those physical traits look like on you, as well as what the genotype is that causes that. So if you scroll down to this chart right here, this is a pretty confusing looking trait or confusing looking chart. We're going to break it down together. So on the left-hand side of this chart, I've got a bunch of dominant traits that you may have. So maybe you have a widow's peak. Maybe you can roll your tongue. Maybe you have a cleft chin. These are all dominant traits. And can someone remind me again, when we're talking about dominant traits, are we using capital or lowercase letters?
Capital.
Capital, right? So we're going to be using capital letters to describe these dominant traits. But there are actually two ways that you can have a dominant trait. You can either have two capital letters, so like a big R and a big R. But there's also one more option. What is another way you can have a dominant trait?
Heterozygous thing, right? So like
yeah, heterozygous dominant as well. Remember we talked about if you have a combination of alleles, if you've got one dominant and one recessive, think about me and Dwayne "The Rock" Johnson going up head to head in a fight. Who's going to come out victorious? Oh, Dion says me. That's so sweet of you to think. But no, I would be pummeled straight into the
The
ground.
geese.
The geese would win. You're right.
The
You're right.
geese.
But no, Dwayne The Rock Johnson is going to win that fight, unfortunately. So whenever you have a dominant and a recessive trait come together, that dominant one is always going to win. It's always going to show up and kind of hide that recessive trait. So I think someone mentioned that this is called heterozygous dominant. What does that word hetero mean?
It means different.
Different, right? So we've got two different alleles. So then how do we describe this one over here that has two of the same alleles?
Homozygous.
Amazing. Homozygous dominant. All right, so those are our dominant traits. But there's also one way that someone can have a recessive trait. And what is that one way? Yes, I'm seeing it.
Homozygous recessive.
Homozygous recessive. This is the only way you will have a recessive trait is if you've got two of those recessive alleles. So homozygous recessive. Again, homo means same, so we've got two of the same allele. Elion says, why would he want to beat you up? I don't know. Maybe Dwayne The Rock Johnson has some personal vendetta against me. I don't know. Maybe something I did in a past life. All right. So now we figured out what these dominant and recessive traits are, but we're also going to be looking at phenotype and genotype of these characteristics. So when we're looking at this word phenotype, again, we're talking about the physical characteristic or the physical trait that you have. And when we're talking about the genotype, we're talking about the combination of alleles that you have. Okay. So I'm going to give you the first example of what we're going to be doing. So the first picture I'm going to show you guys is a picture of someone who can roll their tongue and a picture of someone who cannot roll their tongue. If you can roll your tongue, you would be considered a roller, which is the dominant characteristic. So if you have the dominant trait, you're going to be writing down two possible genotypes. So you would either be homozygous dominant or heterozygous dominant for that trait. But what happens if you're not a roller? If you cannot roll your tongue, what would your genotype be? Exactly, lowercase r and lowercase r. So we're going to be looking through a series of pictures and characteristics, and it's going to be your job to figure out whether or not you have these characteristics and what that makes your phenotype and genotype. But I do want to say, pay attention to the letter that's beside these traits. Not all of them are going to be R's. Some of them are W's and E's and H's. So just make sure you're writing down the correct letter. All right, are we ready to get started? Let's do it. All right, I'm going to pull up the pictures we're going to be flipping through. That's not right. Go back. All right, our very first trait is whether or not you can roll your tongue. So if you are like the guy on the left who can roll his tongue, that is the dominant characteristic. If you cannot roll your tongue, that is the recessive characteristic. So go ahead and fill in your phenotype and your genotype on your chart.
Is the chart in Google Classroom? Because I didn't see it.
Yes, it's on, the assignment is called Genetics Day 1 Classwork, I believe.
Okay, thank you.
Miss Colin,
What's up?
I'm confused on where to put it. Like, I'm still a little bit confused about the chart. It's like
For sure.
the phenotype and the genotype. I don't know.
Yeah, so the phenotype is going to be your physical characteristics. You're either going to write a roller, so like you can roll your tongue, or you cannot roll your tongue. And then the genotype, if you have the dominant trait, so if you have the trait that's in the left-hand side of this chart right here, you're going to either write down, or you're going to write down both capital R, or capital R, lowercase r. But if you have the recessive trait, you're going to be writing down lowercase r, lowercase r.
Okay.
Is
So
that a
if
little
I
bit
can,
clear?
I would put 2 capital R's.
Correct. So you would write down 2 capital R's, but also this capital and lowercase r. So make sure you write down both of these combos if you're dominant.
Okay.
And under phenotype, I write roller if I can roll my tongue like this, right?
Correct. Yes.
Mm-hmm.
So for the phenotype, you can just write down the characteristic you have. So you'd be writing down either widow's peak or straight hairline. You can just write down whatever the characteristic is. Does that make a little bit more sense? All right. Are we ready to move on to our next trait? Oh my gosh. These people are banging against my window. All right, let's move on to our next trait, and that is a widow's peak. So if you have a widow's peak or kind of this triangle in your hairline, that is considered the dominant trait. But if you have a straight hairline like this, that is the recessive trait. Yes, Lauren, that's correct. So if you have the dominant trait, put both of the possibilities. Yeah. So Ian, yes, you have a widow's peak.
Okay.
That is dominant, my friend.
Okay.
I have like a little bit of one, but it's not, well, yeah, it's kind of obvious right there.
Yeah, that's what sometimes confuses me with genetics, because it's either dominant or not, but then how is there an intermediate, right? Is there a
So
problem?
that's getting, yeah, so we're kind of simplifying this into a little bit simpler terms than it really is. There's also something called incomplete dominance, which basically means that multiple genes work together to influence a trait. So it's not always so black and white. There's kind of a lot of gray area in between of like how these characteristics come to be. All right, moving on to our next trait, we've got either attached or unattached earlobes. So if you can look at your earlobe and your earlobe is kind of floppy, it's disconnected from your head, that is the dominant trait. But if the bottom of your earlobe is connected to your head, that is the recessive trait. So yeah, go ahead and feel your earlobes, see if they are connected or not.
I think I'm in between.
Let me see, put it in the camera. Not to be weird, but.
Like, I feel it like
That's,
attaching to the thing, so like my head and not the ear itself.
so it looks like yours are unattached because they can like move around a little
Yeah,
bit.
like,
So I would say those are unattached.
okay, so I can.
Miss
Right. Yes, what's up?
I'm sorry, I keep getting a little bit confused about it.
No,
So
good.
I have a straight hairline, so I would just put capital R and lowercase r.
Well, look at this. So the straight hairline is actually recessive. So which alleles would you write down for a recessive trait?
So 2 lowercase r's.
2 lowercase r's, correct.
Yeah.
So
Got it.
if your trait falls under this dominant category, you're going to be putting both of these options. If it falls underneath the recessive category, you're only going to put 2 lowercase.
Okay, thank you.
Of course. All right, our next trait is hitchhiker's thumb. So this is actually backwards, I'm going to clarify. This is the presence of a hitchhiker's thumb, and I'll show you what that looks like in just a second. So if you look in your camera right now, I've got really bad hitchhiker's thumbs, meaning my thumbs bend like all the way back if you can see me in your screen. So if your thumbs bend backwards like mine, that is a hitchhiker's thumb, and that is the recessive trait. But if your thumbs do not bend back like mine and only go straight like this, I can't even make my thumb do it, that is the dominant trait. Right? So if you can bend your thumb backwards, that's hitchhiker.
Do we do a double lowercase r if we have the recessive? Or is it just one
Yeah,
lowercase
correct.
font?
So write 2 lowercase. Yeah.
So I think I have like the regular thumb.
Yeah, yours looks pretty straight to me. So that's the dominant. Caden says, my thumb has 3 joints. Does that count as hitchhiker's thumb? So if you can bend your thumb backwards, oh my gosh, that's going to be hitchhiker. Ian looks disgusted at my thumb. Isn't that nasty? Right. Any other questions about that? All right, let's move on to the next trait, which is cleft chin. So if you have a cleft chin like this one on the left, if there's like a dent or a dimple in the middle of your chin, that is the dominant trait. If you do not have a cleft chin and your chin looks pretty smooth, that is the recessive trait. Let's see, Yuna says, I'm able to do it straight, but also backwards. If you have the ability to move it backwards, that's a hitchhiker. Yuna says, oh. Right, take about 10 more seconds with cleft chin, and we'll move on to the next. All right, now I want everyone to stop what you're doing and clap your hands together like this. So intertwine your fingers, basically hold your own hands. Now, when you did this, did you put your right thumb on top or your left? If you put your right thumb on top, that is the dominant trait. If you put your left thumb on top, that's the recessive trait. So when you put your hands together, which thumb is on top? Right on top is dominant, left on top is recessive.
Left on top, gang. Let's go.
Oh my God, Ian's in the recessive crew.
This
How
is
many
the
of us are
first
right?
recessive I've had in this entire
Dion
talk.
says, Dion says right
tried
only.
it, I tried to do it the other way around, but it feels weird.
Yeah, that's how you know if it feels weird when you like.
Oh my
It just
God, we've got a lot of lefties in here. Let's see, Samuel, Aaron, Yariel, Caden. Oh my gosh, Ian, you're in a good crowd. Where are my righties at? Dion, are you in the right gang? Okay, it looks like it's just me and Dion. Oh, Adrian's here with us too. Joseph, okay, perfect. So we're evenly split. Lauren put right on top as well. Amen. Caden, what's up?
Wait, is the picture like backwards or something, or like mirrored or something? Because it shows, you said left. Wait, did you say left thumb on top is dominant?
Left on top is recessive. So yeah, these pictures
Oh,
should be
okay.
backwards. That's why I like wrote down dominant and recessive on them. Yeah. Right. Patience is right on top as well. Okay, so we've got a good crew. All right, just a few more traits. Next up, we've got dimples. If you have dimples on your cheeks when you smile, that is the dominant trait. If you do not have dimples, that is the recessive trait.
What if I only have on one side?
If you only have it on one side, consider that you do have dimples. So that I would say that's a dominant.
I don't think I have them.
Ian is smiling. Let's see, does he have dimples?
Like sometimes I can see like a tad bit of a bend when I smile lightly, but no, I don't have.
Yeah,
dimples.
Like if I
Dimples is recessive or
dimples is dominant. So not having dimples is recessive.
okay, that's weird.
Joseph says, what do I put in for the phenotypes? That is the physical trait. So you would either write dimples or no dimples. All right, and last but not least, we've got freckles. If you've got freckles on your face like this person on the left, that is the dominant trait. If you do not have freckles, that is the recessive trait.
I have like something here, but I don't think that counts. I think that's just something.
Yeah, I have a few freckles on my arm, but not enough to count.
Like here, 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 I guess. A couple around here. But no, I don't
Oh,
have
Caden,
freckles.
freckles. Freckles are so cute. All right, now that we figured out what our genotypes are, let's do something with it. Moving on to my favorite activity and something Ian has been looking forward to, and that is Punnett squares. So for those of us who have used Punnett squares before, can you tell me, why do we use them? What's the point? What are
To
we
like
trying to figure out?
figure out the probability of like there being like something happening. So for example, like
Okay,
the probability of having a phenotype, I think is
perfect. Okay, so yeah, we're trying to figure out the probability of offsprings or potential offsprings genotypes. So if we're trying to figure out the genotypes of potential offspring or potential kids, who do you think we're going to be putting in this Punnett square? We're going to be looking at two, what?
parents.
Parents, right? So we're going to be crossing the genotypes of parents. Right. So last night, I gave you guys an example of a trait that runs in my family. What trait was that?
The brown hair.
Yeah, either brown or blonde hair, right? So I've got brown hair, but my brother has blonde hair.
Hey,
Now, which one of those do you think is the recessive trait, brown or blonde hair?
uh,
Blonde, right?
blonde. Yeah.
So in order to have blonde hair, he must have had two recessive copies of that allele. So two lowercase letters. But for the dominant forms, it could either be big B, or big B, little b. So this would be brown. I'm actually going to do that in a different color. Hold on. Right. So this would be brown hair, and this would be blonde hair. All right, and just based on this observation, I was able to figure out what genotype my parents have that was able to give my brother blonde hair. What genotype would my parents have to be in order to have a child with blonde hair and a child with brown hair? Yeah, Apostolos got it. So both of my parents had to have been heterozygous dominant for brown hair. So with these Punnett squares, we're going to be crossing those genotypes to figure out what's the probability of them having kids with each of these genotypes. So how do we set this up? I'm actually gonna move this down a little bit so I've got some more room. Now, I should have said this earlier, but this is the one time in class where I would say if you are working on a computer, go grab either a sheet of loose leaf or some paper so you can jot down what I'm doing as I go through this. This is something that's pretty difficult to do on the computer. So even if you're like working on the notes app of your phone, it might be easy, or it might be better to have somewhere you can write. Okay. So yes, Apostolos, if you're working on like an iPad, try to fill it in. But if you're on the computer, you might want to just do this on some loose leaf. All right. So both of my parents must be heterozygous dominant for brown hair. So how are we going to set this up? If we're crossing the genotypes of my parents, how do we put that on this chart? Well, we're going to put one parent on the top, so we can put my mom's genotype on the top and my dad's genotype on the side. So we're going to break this genotype apart. So let's say this is my mom and this is my dad. Mom's on top is going to be big B, little b. Dad's on the side is going to be big B, little b. And now what do we do from here? So we've got our chart set up. We know we're going to be crossing the genotypes of these parents, but what happens next? Someone in one of my other classes was saying that this looks a lot like, is it the box or the square method that you guys do in algebra? Is that correct? Yeah. Okay, so what do we do with the box method or the square method? So the first thing, the box method, thank you, Eunice. Let's first focus on this top left box. What two things are we going to multiply together for this top left box? Ian, go for it.
Uppercase B.
B and B. Yeah.
Yeah, so uppercase B and uppercase B. Right, now, Caitlin, what are we going to do for this top right box?
It's gonna be uppercase B and lowercase b.
Perfect. What about this bottom left box? Let me hear from Samuel.
It would be B and then lowercase b, or uppercase B and then
Perfect.
lowercase.
Uppercase B and lowercase b. One thing I do want to say about this is that the uppercase letter always comes first. So we're never going to write it lowercase b, uppercase b. It's always going to be uppercase first. All right. And then for the bottom right box, what are we crossing together? Let me hear from Becky. What'd you get for that?
Small b and small b.
Perfect. Lowercase b and lowercase b. So for each of these boxes, you're only multiplying what's underneath each row. Right? So now looking at that chart of the potential genotypes, let's figure out what are the chances of a homozygous dominant trait. So homozygous dominant, remember homo means same, and if it's dominant, what is that letter combination going to be?
2 uppercase or an uppercase and a lowercase.
Perfect. 2 uppercase letters. So looking at this chart, what's the probability that we're going to have a kid with uppercase or 2 uppercase letters? Let me hear from Eunice. What do you think?
Both capital or 25%, 1 out of 4.
25%. Yeah, because we see that there's just 1 out of 4 chances that you're going to be homozygous dominant. And that's 25%. You're right. All right. What about homozygous recessive? So we're still looking for the same, but since it's recessive, we're looking for 2 lowercase letters. What is the chance of that? Kaden, what'd you get?
25%,
Perfect. And how'd you get that?
because there's only 1 out of 4 with double lowercase b's.
Amazing. And then finally, what is the chances of a heterozygous dominant child? Let me hear from Lauren. What'd you get for this?
Can you repeat the question? I was trying to follow
Yeah, for
along.
sure.
I'm still lost.
You're good. So what are the chances of a child inheriting the heterozygous dominant? So remember, hetero means different. So we're going to have 2 different copies of those alleles, 1 uppercase, 1 lowercase.
Is it is it gonna be associated with the fourths? Because you see how you put like 1/4 and 1/4?
Correct. Yeah.
Like 50%? Because
Yeah. And how do you get that?
100, 25, 25, and 50.
Perfect. You're exactly right. So in this example, let me do my colors the same. There's a 2 out of 4 chance that that child is going to be heterozygous dominant because we've got 2 that are 1 big B and 1 little b. So that is a 50% chance of inheriting a heterozygous dominant genotype. Okay, but what if we're talking about inheriting a phenotype? So what are the 2 possible phenotypes for this trait? Remember, that's the physical characteristic.
With blonde hair or with like blonde or brown hair?
Perfect. Either blonde or brown hair. So can someone tell me what is the likelihood or the probability that my parents' children would have brown hair?
75%.
And how'd you get that?
Because 3 out of the 4 combinations that we got give us positive, like give us an outcome in which the recessive, in which the dominant trait comes out on top.
Perfect. So remember that that dominant trait is always going to overpower the recessive trait. So anytime we have even one capital B, a dominant trait is going to be present. So both the homozygous dominant and the heterozygous dominant give us a chance of having brown hair. So that is 75% probability that my parents had a brown-haired kid. And what's the probability of them having a blonde-haired kid? 25%, right? Because there's just one outcome in which there's 2 lowercase b's. All right. How are we feeling about this? Good, bad, terrible, fantastic? Makes sense? Okay. All right, so do not worry about going over these next 2 examples. We're actually going to do those at the beginning of class tomorrow. Yeah, Aaron says it's a little confusing at times, but okay. This is complicated, so that's why we're going to do some more practice with it tomorrow. So you guys will be experts in no time. But tonight, your homework is to watch your genetics day 2 video. So I'm about to record and upload that, so it'll be up probably within the hour. That is your homework for tonight. Again, do not worry about completing these or turning them in. We will do these in class tomorrow. All right, what questions do we have before I let you guys go?
Miss,
What's up?
do we have to like copy the part where you were writing in the box? Because like I keep trying to click on the box, but like it won't.
You should do a piece of paper that has the time.
Are you talking about like these boxes over here, the actual Punnett square?
Yeah.
Don't worry about writing in those. I think I set it up on Google Classroom where you can double click on that image and then type it in the drawing section. So if you can do that, you're more than welcome to. But it was probably easier if you just write this on loose leaf with a pen and paper.
Okay, got it.
Yeah, up to you. All right, yes, Jocelyn, I am going to upload this video to Google Classroom. And Eunice says, is curly hair recessive or dominant? I actually don't know. I'd have to look that up to confirm. But that's my homework for the day. I'll let you know tomorrow. Eunice says, I want to know if I have dominant genes. Don't we all? All right, guys, that's all I've got for you today. So again, don't worry about completing these next 2 examples. We will go over them in class tomorrow. Your homework is to watch your genetics day 2 video and complete those notes and exit ticket before tomorrow morning at 8:30. Have a wonderful day, and I will see you guys tomorrow.
So we don't have to complete the classwork for homework.
No, don't worry about it. We'll finish it in class tomorrow.
Okay.
Okay, thank you. Bye.
Have a good day.
Bye. See you guys later.